After segmenting your CNV chip data, you will find a new genome view attached to your log2 ratio omic data, as well as a folder under the Table section containing your segmentation data in a table and several views. The genome view attached to your omic data object shows 2 charts per sample per chromosome. Under the View controller, we can filter for a specific chromosome. Let's look at chromosome 12. For each chromosome in each sample, you will find 2 charts. One plotting the log2 ratio signal along the chromosome, and the other showing the B allele frequency. You can switch from B allele frequency to frequency deviation. This will emphasize regions with potential loss of heterozygosity. You will also see predicted copy number call regions according to the legend. Under the Table section, under your segment data, you will find a table view where each predicted segment for each observation will be plotted in a table along with a copy number status. The associated views are visualizations of these data. In the scatter view, for each sample, the B allele frequency deviation is plotted compared to the log2 ratio of the signal. Each segment is colored according to the predicted copy number status. We can change the plot to show both normal and tumor in the same view. We can also force a uniform scale. We can see in the tumor sample a number of segments that have higher than average log2 ratio signal, indicating possible copy number gain. We can select these to view the details in the Details window. We can see that most of these high copy number regions occur on chromosome 12. We can also filter for a specific copy number call. These are the regions called as 1 or 2 copies or loss of heterozygosity, which will have a large B allele frequency deviation. We can filter for large segment size, this is plotting only segments that are at least 1 megabase in length. We can see that most of these segments occur on chromosome 10. The segment view allows you to compare your samples by plotting the log2 ratio of the segments along each chromosome. Again, let's filter for chromosomes 10 and 12. We we can see in our tumor sample a nearly chromosome-wide loss in signal compared to the normal control. While on chromosome 12, there's a small region with significantly increased log-2 ratio signal. Hold down Shift and select the region to zoom in, and turn off vertical scrolling. Select these regions to see additional details, or switch to the segment chromosome view. The segment chromosome view displays copy number predictions along each chromosome. Different views attached to the same data object will share, filtering, and selection status. So we only see chromosomes 10 and 12, and we can see the region selected under the segment view here in the segment chromosome view. If we switch to the tumor sample, we can see that the region selected in the segment view has a small region called as a very high copy number. In contrast, chromosome 10 is called as loss of heterozygosity. We can remove the filters to see all of the chromosomes. You can switch back and forth between normal and tumor, so you can see the regions on each chromosome that are affected by copy number variation. This might include whole chromosome changes or focal changes. As with other views, selecting a region will display details in the Details window. If you have a Genome Browser session open in the Genome Browser tab, you can right-click on a detail and view the region in the Genome Browser. You can add the tracks from your analysis directly onto the Genome Browser. For example, your segmentation data. Zoom out to see that several regions in this area have copy number variations, including a significant amplification of this region.